Hello, physics quantum theory, Compton effect. In a Compton effect experiment, a wavelength of photon is zero point 0.1 nanometer. That photon strikes an electron, and uh, this is experiment, and use the relativistic energy and momentum formula to determine the kinetic energy of electron and the wavelength of the recoil photon. So, two things we have to determine. Uh, Kinetic energy and the lambda dash. So before and after the collision. Before the collision, and this is photon, this is electron, this is photon, this is electron, this is momentum. Momentum of the photon is h over lambda. Momentum of the photon 0. H over lambda dash, and the momentum of the photon is PE, electron. Energy is HF, and the energy of the electron is rest mass energy, m naught c square, and the energy of the photon HF dash, and the energy of the electron is 2PE over 2m, and that's changed to relativistic mass from m naught to m. So now we have to use the conservation of momentum. So before and after is equal. So that will be HF, h over lambda plus 0 is equal to h over lambda dash plus PE. So this gives us that HF lambda dash is equal to h over lambda minus PE. Minus PE. No, this is negative because it's recoiling. So this is negative. So it's a negative. So that will be on this side. That will be on this side. So which will be a negative. So first photon will go this way, and then afterward photon will come this direction. First photon will go this direction, and after the hitting, that photon will come back, and electron will go in this direction. So this will be negative. So HF minus this one. So we will see this momentum. So H over lambda dash is equal to minus H over lambda plus PE. This is equation number 1. So in term of H dash, because we have to find this value, so we have done this one. Now the conservation of energy. Conservation of energy. So HF, we can call it HF. HF, it can be written as HC over lambda. So HC over lambda plus m naught c square is equal to HC over lambda dash. So this will be hf dash hc over lambda dash plus this one. It can be relativistic, so it can be written as m naught c square whole square plus pe square c square whole under root. This one. And here for this term, we can approximate. We use 1 plus x raised power 1 over 2 is equal to 1 plus 1 over 2x plus so on. If x is very, very small to 1. So in this case, this will be equal to hc over lambda dash plus m naught c square plus pe square over 2 m naught and this is equal to hc over lambda plus m naught c square. This cancel, so we have got this one pe square over 2 m naught and plus this one plus hc, this term we can use this term here, so hc over lambda, so c will be multiplied, so this one minus h over lambda plus pe and multiplied by c and this one is equal to hc over lambda. This one, this will go on this side, it will be doubled, so pe square over 2m naught plus pec plus is equal to 2hc over lambda. So this is a quadratic term, quadratic equation in PE. So we can solve this one using all the constant. This is constant, C constant, H constant, lambda is given. So the value of PE, the momentum, is equal to 1.295 into 10 to the power minus 23 kilogram meter per second. If you have this one, then we can find out the kinetic energy. Then kinetic energy Ke is equal to Pe square over 2m naught. So if you use this one, m naught is 9.11 into 10 to the power minus 31 kg. So this is m naught. If you use this one, then the kinetic energy is equal to 9.21 into 10 to the power minus 17 joule, or equal to 0.576 million electron volt. So this is or 576 electron volt. So now we have to find the second part. This is the first part done. Now we have to find the second part. Second part says that we have to find the this equation, h lambda dash is equal to minus h over lambda plus pe. Pe is known, which is 1.295 into 10 to the power minus 23 kg meter per second. This value, this is known 6.7 into 10 power minus 34 joule second H, and lambda is equal to zero point 0.1 nanometer. So from this one we can find out the value of the wavelength, which is equal to 0.105 nanometer. So the wavelength will change from lambda to lambda naught, from 0.1 nanometer to 0.105 nanometer, and energy of the electron will be 576 electron volt. That is the answer of this question. This is slightly difficult calculations.